Okay. I am Dr. Babu, Professor and Head of the Department of Biomedical Engineering. Now I am going to explain about the origin of bioelectric potential in this video. Okay. So, the origin of bioelectric potential, in our body we are having many kinds of bioelectric potential like ECG, EEG, EMG, like that. These biopotentials used to be recorded to know about the pathology of the particular organ of the body. For that we have to record the biopotential. Before that we have to know what is the origin of this biopotential, how these biopotentials are produced in our body. The systems in the human body generate their own monitoring signals when they carry out their functions. That is the biosignals. Biosignals generate their own monitoring signals. These signals provide useful information about their function. Bioelectric potential are actually ionic voltages produced by result of electrochemical activity of certain cells. So that we are using transducer to convert this ionic potential into electric potentials. So this is the basic of the biopotential. Then we can go for the resting potential and action potential. What is resting potential and what is action potential? Okay. Certain types of cells within our body, such as nerve and muscle cells, are encased in a semi-permeable membrane. The basic cell, the outer layer is equal to membrane, that is naturally a semi-permeable. This membrane permits some substances to pass through the membrane. At the same time, others are kept out. Surrounding the cells of the body are the body fluids. These fluids are conductive solutions containing charged atoms known as ions. So, to know about the resting potential and action potential, this is the diagram. Okay. So, this is a first cell. First diagram, it is a cell, basic cell. In this basic cell, because of the sodium, potassium, chloride ions, the cells formed in the, some potential formed in the inside and outside. Generally, the concentration of the sodium ion is outside more, and the concentration of the potassium and the chloride is equal to inside more at the resting state. So, due to the permeable membrane, the sodium ion which is available outside with more concentration tries to goes inside the cell, and at the same time the potassium and chloride which is having positive potential and the chloride negative potential tries to come outside. At the equilibrium, sodium will be more in the outside and the potassium and the chloride will be more in the inside. So there is a equilibrium state formed. At this equilibrium state, if we measure the potential of this cell inside to outside, that is called resting potential, and the value of the resting potential is nearly minus 70 millivolt. So this is the explanation of the first diagram. So there is same diagram which is explained in different way, in rectangular way. So now the cell is depolarized because of the stimulus. If the stimulus is applied to the cell, so depolarization starts. Because of the depolarization, what's happened? The semi-permeable membrane property will be changes. So because of the change in membrane property, the sodium ion which is having outside higher concentration will goes inside, and inside potassium and chloride ion comes outside. So this is called depolarization. So the potential is altered from the minus 17 millivolt because of the inside and outside going of the ions. So the potential will keep on increasing. This is called deep starting of the depolarization. Okay, this is the second rectangular cell which explains about the same function. Okay, after the cell is completely depolarized, we are getting now this diagram, third diagram. Now the outside of the cell is completely negative and the inside of the cell is completely positive when the cell is completely depolarized. When the cell is completely depolarized. So in this case the potential is measured inside to outside. Now the potential of the cell is equal to plus 20 millivolt. Okay, this is the depolarization. Okay, after some time the stimulus is not applied, then the cell is tried to come to the initial position. Again the repolarization starts. From the depolarization completed state, again the repolarization starts. So again outside of the cell is positive and the inside of the cell is equal to only negative. So it is completely repolarized. Now it just comes to the initial state, that is minus 70 millivolt. So this diagram explains about the action potential and the resting potential. When cell is at resting state, the potential of the cell is equal to minus 70 millivolt, that is called resting potential. When cell is depolarized because of the stimulation, okay, the cell potential is equal to plus 20 millivolt, it is called depolarized state, it is called action potential. Okay, the same process can be explained in the graph. Okay, x-axis we are having time and the y-axis we are having voltage. Initially the cell is equal to minus 70 millivolt. The resting potential is different for different cells. Basic cells it's equal to minus 70 millivolt. At the same nerve cells, muscle cells having the different action potential, and the nerve cells also having up to minus 90 millivolt. So if you take the basic cell, it is resting potential equal to minus 70 millivolt. Due to the stimulus, okay, if the stimulus is equal to above the threshold value, again the depolarization starts. So the curve is keep on going up to plus 20 millivolt. This is called depolarization. This is called depolarization. When comes to the maximum, again the cell is completely depolarized. After that, because of the no stimulus given, so the cell tries to come to the initial position again. So the cell is starts to repolarize and comes to the initial condition, that is called polarized cell or resting potential. So plus from the minus 70 millivolt it goes to maximum of plus 20. Again because of that is due to the depolarization, and because of the repolarization again comes to minus 70 millivolt for the basic cell. So this is the time we are having the depolarization, and this is the time we are having the repolarization. These two will be happen within 2 milliseconds. This is the diagram explanation for the depolarization and the repolarization. So the same thing is explained here. Okay, sodium potassium chloride. The membrane of excitable cell permits entry of the potassium and the chloride ions but blocks the entry of the sodium ion. So inside the cell is more negative than the outside. Whatever I have explained, the same thing is explained in terms of words. This membrane potential is called resting potential. The resting potential ranging from minus 60 millivolt and minus 70 millivolt. Cell in resting state is called polarized cell. After the membrane change its characteristics and starts allow sodium ions to pass through it. Okay, this is the same thing. Diagram, action potential diagram. Now the cell has slightly positive potential on the inside. The potential is called action potential. The process of changing from the resting state to the action state is called depolarization. So these are the some of the examples. These are the some of the examples for the action potentials of the different signals. ECG type of electrode we are using the skin electrode, and this is the signal characteristics. So ECG, EEG, EMG, ERG, EOG, these are the some of the bioelectric potential and their characteristics and the type of electrode we are using for the measurement. So this is up to the resting potential and the action potential of a cell. Okay, this primary characteristic, signal characteristics, it shows about the frequency and also frequency range and also signal amplitude that is different for the different signals. Up to this we have completed our resting potential and acting potential. Thank you.